Am I audible, guys? Hello?
Yes, sir.
Yeah, let's wait for 2 3 minutes more because people are still joining and then we will start. Hello.
Hello, sir.
So can we have a introduction, short little introduction about yourself, so I know a little bit background. Am I audible to everyone?
Yes, sir.
You can all unmute yourself and speak about yourself in one two line. Yes,
I
starting
am
from
Vijay,
you only,
senior lecturer
Praveen.
in an engineering college.
Yes, can you start once
Myself,
again?
Vijay Kiran,
Yeah, yeah.
working as a lecturer in assistant engineering college, Ongole, in
Okay,
an engineering college.
okay, okay. Nice. Now, next, anyone wants to introduce?
Sir, my name is Chintamani Chaudhary. I am from Barampur, Odisha. Now I am pursuing MCA at Barampur.
Okay, very nice.
Good evening, sir. I am Shika Rathod from Vanasthali Vidyapeeth, pursuing BTech fourth year.
Okay, okay, very nice. Anyone else? We have 12 participants. I got 3 introduction. So I wish everyone will proceed and tell one by one.
Good evening, sir. My name is Divya Gupta. I am from Vanasthali Vidyapeeth. I am pursuing BTech from Vanasthali Vidyapeeth. I am in fourth year now.
Okay, good. Anyone else wants to introduce?
Good evening, sir. My name is Manolita Sahu. I am from Barampur, Odisha.
Okay, very nice. Okay, so I will start the week 1 discussion of this course, Introduction to Soft Computing. So myself, Ayan Paul, I am PMRF Research Scholar from IIT Kharagpur, and course name you know, Introduction to Soft Computing, and course code NOC23-cs40. This course is taken by Professor Devasi Samanta of Department of Computer Science and Engineering, IIT Kharagpur. So we will be starting our week 1 discussion today on 7th February, and I am very excited. We will take 8 weeks discussion, so this is our first week. So let's start. I think I am audible to all of you, right? And my slides are visible. Hello.
Yes, sir. Audible.
Okay, and my slides are visible.
Yes.
Okay, okay, very nice. So as it is an engineering course, so I want to start by telling you the steps followed to solve any engineering problem, right? So I am telling here only for engineering problem, but this is applicable to all your real life problem. So first we start with what is our input and what is our output. So we divide the variables mainly into two groups. One part is input and the part is output. This can be related with a real life experience, like you are going to a market to buy a vegetable. So what will be your input? Your input will be money, right? And output will be the vegetable you are getting. So this is your first step. The input variable is also called condition variable or antecedents variable, and the output variable is called action or consequent variable. And the second thing, what you are interested to have a relationship between your output and input. Like the example I have given is vegetables, right? So you will be interested to know the relationship, mathematical relationship, like like 1 kg of vegetable will cost what, rupees 30. So you will be interested in knowing how much input you will give to receive a particular amount of output. So this is your second step. And in engineering we relate this output variable to the input variable with some mathematical equation. Like in real life I have told you a simple linear equation, like 1 kg of vegetable 30 rupees. In engineering problem, what we do is a little bit complex mathematical equation, like differential equation. Our third step is to solve the differential equation analytically or by numerical method. Like I am interested in buying 2.5 kg of vegetables. So I will be interested to solve how much money I want to give the shopkeeper to get that required amount of vegetable. So this is our third step. And fourth step, once we got the solution to this third step, the differential equation or any equation, like in our case 2.5 kg of vegetable will cost 75 rupees if 1 kg costs 30 rupees. Like what we will do is this solution as an input is fed to the system, and we will give that 75 rupees to the shopkeeper to get our required vegetables or required output. So these are the four steps to be followed in any engineering problem. So I have started with this because these are the four steps, and this is nothing but hard computing. 1 minute. So computing means calculating basically, right? And here we are calculating with some mathematical equation or some differential equation. So that is why this type of computing is known as hard computing. And this term is introduced by a professor named L.A. Zadeh of University of California in the year 1996. So I hope this slide is clear to all of you. Can I get a response?
Yes, sir.
This is clear, right? All of you? You can write in chats also.
Yes, sir.
Okay, very nice. So up to this is clear. So the thing with examples of some hard computing is anybody from mechanical here? Mechanical engineering or something? Some branch related to mechanical? I'm not getting the response, so I believe nobody is from mechanical. So in mechanical, what we do is when we make any component like machine or anything, we do the stress analysis. And how we do the stress analysis? We do the stress analysis by a method called FEM, finite element method. So in this what we do is we break the not literally break it, we just divide the thing in various small elements and we calculate stress at each of these elements. So this is known as stress analysis using FEM. So this is a type of hard computing. We are calculating stress at each and every element. So this is known as hard computing. First example of hard computing. Second example is PID controller. PID controller is proportional integral derivative controller. This is a type of controller which calculates the error value and then control the process, and this is also done by hard computing. In this we calculate the error by differentiating between the desired set point and what we are giving. Desired set point is your target and what we are getting output. So the error value is calculated and then it is fed back to the system to calculate to again calculate output 2. So this is known as a PID controller, and determination of gain value is done by this process hard computing, because we are computing, we are calculating, right? So 1 minute. Yeah, so we are calculating it. So this is another example of hard computing. So what are the features of the hard computing? So first, as I have already explained, it is based on pure mathematics, like what we are doing is we are relating the output to an input by some sort of mathematical equation. So it is based on pure mathematics. Second thing is it yields precise solution. Okay, there are two things, accuracy and precision. So can anybody tell the difference between these two, accuracy and precision? Hello? Am I audible?
Yes, sir.
Okay, so can anyone tell the difference between this things, accuracy and precision? You must have read in class 11th or something, somewhere like class 11, class 10, accuracy and precision. Anyone can have a try? Yes, very good. Ashjad Quresi, very good. Accuracy means how much it is closer to the actual answer, right? Very good. And what is precision? Anyone wants to try? Okay, no problem. Accuracy is a degree of correctness. Yeah, precision also Divya Gupta has written. Precision, how close the measured value are to one another. Very good. So precision is a degree of repeatability. Degree of repeatability between measurement of same physical quantity. Means you are measuring a physical quantity, and how close this measurement are to each other. This is known as precision. And accuracy is degree of correctness, means how close the measure value is to the correct value. This is known as accuracy. So here what this hard computing yields? Hard computing is precise solution, means this measured values will be very close to one another. And third features of hard computing is it is suitable for problems which are easy to model mathematically. As I have already told in the first point, it is only hard computing is only possible if you can have a mathematical relation between your output and the input. and fourth is it may not be suitable to solve complex real life problem. So here this is the very limitation of hard computing. For that we will introduce soft computing in later stage of this presentation. So what happens is our real world problems are very complex and dynamic in nature. Even if you are bicycling, it is very 1 minute. Yeah, so even if you are bicycling, it is very difficult to mathematically model the problem, because when you are doing any real world problem, it is very dynamic in nature. It is changing at each and every instance. So you cannot have a mathematical equation for each and every instance. Solve the mathematical equation, have the solution. 1 minute. Yeah, so you cannot have a mathematical equation for each and every instant, solve it, and then have the output. It is not possible in real world problem. This is the main disadvantage of hard computing, for which soft computing is introduced in later stage. So I will now introduce you all with soft computing. So soft computing, it was introduced by Professor Zadeh in 1992. So yeah, here you can be surprised that soft computing is a modern thing, right? And hard computing is a traditional thing. But the year soft computing introduced is 1992, whereas here you can see hard computing is introduced in 1996. So how is it possible? Actually, Professor L.A. Zadeh introduced this term soft computing first, and when he was asked, you have introduced soft computing, what is hard computing? Then he came out explanation of this term hard computing. So that is why soft computing, the year is in which it is introduced is 1992, whereas hard computing is introduced in 1996. So now about soft computing, it consists of some biologically inspired technique. This is very important. Biologically inspired technique. Yeah, biologically inspired technique. So soft computing is a family. It is inspired by biologically inspired technique. The introduction of soft computing is based on this biological techniques such as fuzzy logic, neural network, genetic algorithm, and their various combined forms. Namely, you can combine this like genetic algorithm and fuzzy logic, genetic algorithm and neural network, neural network, fuzzy logic, genetic algorithm, fuzzy logic, and neural network, in which precision is traded. Earlier I have told that hard computing is very precise, right? But soft computing is not precise. Here precision is traded with tractability, robustness, ease of implementation, and low cost solution. So robustness means it is very strong in nature, that it will not break literally, means it will not when you are computing, it will not the system will not hang or something like this. So it is robust, ease of implementation, it is very easy to implement and have a low cost solution. Again, low cost doesn't means it will be less costly. Low cost means it will take low time. Here cost is in terms of time. So this is your soft computing. So here you can see this Venn diagram. This circle is for genetic algorithm, this circle is for fuzzy logic, this circle is for neural network. So this complete Venn diagram, or you can say that universal set, this is your soft computing. This is your soft computing. Okay, so everyone understood this? Hello? Hello? Am I audible to everyone?
Yes, sir.
Okay, very nice. So you all understood this? This is the basic concept of soft computing. So I want to ask question if you have any doubt regarding this. So it is clear to everyone, right? Can I have a response? Yes sir, no sir, what's... Okay, Harshita is saying yes. I am assuming everyone understood this. Okay, Divya is also saying yes. Okay, very nice. So you are getting something. Okay, so good. So now I have introduced here these three terms: fuzzy logic, neural network, and genetic algorithm. So I am interested to explain you what what these terms are like. So first is this neural network or neuro-computing. So how in our brain information is processed. Anyone can tell this? How in our brain this all this information is processed? Anyone wants to unmute and say something about this? How information is processed in brain? You must have read it in biology, or you must have heard. Okay, no response. So I am telling you how the information in our brain is processed by biological neurons. So our brain consists of many neurons. How many neurons? Around 10 raised to the power 11. Around 10 raised to the power 11 neurons. This are the number of neurons that is in our brain. Now how this information is processed? Information is processed with the help of these neurons. Our information travel from one neuron to another neuron. So this is the concept of our brain, and the weight of our human brain is around 1.2 to 1.4 kg. So by taking inspiration from this, Maculo and Pitts in the year 1943 came up with this term called neuro-computing. Neuro-computing. So in this computing information or processing information is performed by artificial networks of neurons. So with the help of our programming, we design some artificial neuron, and by this we process the informations. So this is on neuro-computing. Second thing is genetic algorithm. Genetic algorithm, you must have all read about this process called Darwin's principle of natural selection in biology. So what happens in Darwin's principle of natural selection is our genes evolved. From the history, our genes is evolving and evolving, and the survival of fittest. We are the fittest that is still alive. Our genes has evolved, and now it now we are humans. So this is the genetic this is the concept of Darwin's principle of natural selection. And Professor John Holland, USA in 1965, introduced this term genetic algorithm based on this. So genetic algorithm is a population-based probabilistic search and optimization technique which works on, as I have already told, Darwin's principle of natural selection. So this is your genetic algorithm. And third thing is fuzzy logic. So fuzzy logic means in binary we have only two values, that is true or false, one or zero. One minute, guys. Okay, so fuzzy logic. So actually guys are still joining, that is why we are having a delay. Okay, nice. Okay, so I am explaining you the fuzzy logic. So so actually computer logic is based on two things, 1 and 0, true or false. This type of logic is known as Boolean logic. But LAs are there, again the same professor, the professor who introduced this soft computing thing. He has some problem with this, because in real life things can't be just two things, right, true or false. There are some uncertainty in our daily process, just like in this class. Your class is from 6 to 8, so you should join at 6 p.m. But no, what you have done is somebody joined 6:02, 6:05, 6:06. Somebody may have also joined at 5:59. So so nobody has joined at 6. So real life problems are like this only. Logic is like this only. So 1 minute. Yeah, so real life logic is this only. So this type of logic is known as fuzzy logic. So fuzzy logic approach of computing based on degree of truth or uncertainty of truth. Here we are not interested only in truth, that is true or false. What we are interested in degree of truth. That means how far you are saying the truth. Like our class timing was 6 p.m. But how close you are to this, means 6:01 is okay, 6:05 is still okay, 6:15 is certainly not okay. So fuzzy logic is the degree of this truth or uncertainty. So idea of fuzzy logic, as I have already told, it is given by L.A. Zadeh in the year 1965. So I hope this slide is clear. So can I get a response from everyone? So am I audible still? Yeah, Divya is telling yes. So you all understood this concept, three concepts: neuro-computing, genetic algorithm, and fuzzy logic. Any doubt? You are please encouraged to ask. No doubt so far? Any doubt you can ask. Okay, so I am assuming that it is clear, or you at least got the introduction, means you got something out of it, right? Yeah, neuro algorithm. Okay, okay, very nice. So, neuro algorithm. So, what I have explained is neurocomputing. What happens is the it is inspired by our human brain. The information in our brain is processed with the help of neurons. We have like 10 raised to the 11 neurons in our brain, and our brain weight I think 1.2 to 1.4 kg. So Maculo and Pitts in the year 1943 proposed this neurocomputing based on this similar thing like our brain. So yeah, detail we will discuss in the I think next class, or 1-2 class later, when we will start this neurocomputing. So as of now, what you understand is Maculo and Pitt, they have designed some programs, and in this programs what they have done is they have designed this artificial network of neurons. So this artificial network of neurons, they will process this information, input information to output information. Like you will give some input, there will be certain layers called the processing layers or hidden layers, and you have this output layer. So you will be giving input. This will form some neurons, and this neurons will be connected to some layer. As of now I can explain only this much, and when we will study in details I will explain the full thing. So this information will be processed in layer, and you will get the outputs. This is neurocomputing. So is it clear, Mini? Am I audible? Okay, very nice. So I hope you get something. I know it will not be 100% clear as of now, because I have not given you any pictorial representation of it. I am just telling you the theory part. So it will be clear in the later classes, that I can promise you all. Okay. So let's again go to the slides. So examples of soft computing is this fuzzy logic and neural network based motion planner for intelligent and autonomous robots. So when you are doing this robotic operation, thing is you can't program everything, right? You need some type of soft computing. You can't program, or you can't mathematically calculate everything. So you need this help of soft computing based on this fuzzy logic or neural network. So by this only you can do the motion planning of this robots. So what are the features of soft computing? First is it does not require any mathematical formulation of solution, like previously I have told, in hard computing you have to make this mathematical formulation of equations and relate the output to the input, but here you do not require any such things. The second point is it may not yield precise solution, that I have already told you, that it cannot yield you as much precise solution as hard computing. Third is function of constituent members are complementary in nature. That means the processes will be interlinked with each other. Means as Mini was asking about neural computing, this processing will be done from layer to layers. That is, all this function that will be used in this are complementary in nature. It will be dependent on the previous one thing. So this is the third point. And fourth point is control algorithm based on this soft computing may be robust and adaptive in nature. This is the advantage of soft computing. It is robust and adaptive in nature, and the disadvantages is it does not yield so much precise solution like hard computing. So this is the advantage and disadvantage of soft computing. I hope this slide is clear to everyone. Can I get a response? Okay, very nice. So this is the thing, and now we have till now studied about two things. One is hard computing and there is soft computing, and both has its advantage as well as disadvantage. Advantage of hard computing is it yields precise solution, and disadvantage of hard computing is it cannot be applicable to real life solution or real complex problem always. So second thing we have studied is soft computing. Soft computing disadvantage is it does not yield so much precise solution, and advantage of it is that it is very robust in nature, and it can yield you low cost solution in terms of time. So these are the advantage and disadvantage of this too. So here we are introducing a third term called hybrid computing to have the advantage of soft computing as well as to have the advantage of hard computing. So soft computing, it is a combination of conventional hard computing and emerging soft computing. So in this, a part of complex real life problem will be solved by hard computing, and the remaining part will be solved by utilizing soft computing. So here we are using both. So here hard computing and soft computing are complementary in nature. You can see by this Venn diagram. This circle is for hard computing and this circle is for soft computing, and the combination of these two is your hybrid computing. So example of hybrid computing: first is optimal design of machine elements using FEM and soft computing. So this FEM part is your hard computing, and after designing your elements by FEM, we are introducing soft computing to it to complete this process. So overall it is a hybrid computing example. And second is PID controller trained by soft computing. PID controller is your hard computing thing, and when it is trained by soft computing, then together this is a hybrid computing problem. So this slide is also clear, I think. Can I get a response? Okay, Harshita is saying yes. Okay, nice, very nice. So as of now everything is clear. Now I will be introducing you with some numerical question of week 1 assignment. That is will be similar to week 1 assignment but not same, because assignment you have to do on yourself. What I will do is I will introduce you with similar questions, so when you are solving the real assignment you won't feel alienated to it. So that I will make sure. So can we proceed? No doubts till now? Okay, nice. So let's take up some questions of your week 1 assignment. Yeah, so topics which are covered in your week 1 assignments: introduction to soft computing, introduction to fuzzy logic, fuzzy membership function, fourth is operation on fuzzy sets, and fifth is fuzzy relation. So we will take up questions related to this topic. So your first question: which of the following problems cannot be solved using soft computing? So first option is option A is robot movement, option B searching and sorting techniques, option C is handwritten character recognition, and option D money problem. So anyone wants to answer this? This you have studied, I think, in that course material that they have given you, NPTEL had provided you. You all had gone through it, the materials. Can anyone try the answer? You can all guess it, A, B, C, D, anything you can write in chat section. Am I audible? Okay, Divya is telling C, Min is telling B. Very nice. Apart from Divya and Mini, I encourage everyone to answer this. Okay. Sankar is here. Sankar Sahu, Surya Pradhan. Are you guys here? Okay, no response. So I think there might be some network issue or something. Harshita, can you answer this? Okay, Harshita is also telling C. Okay, so let me give you the solution. Yeah. So thing is, soft computing I have already explained you. Same thing I have also given this snap from your lecture note. So this robot movement belongs to your fuzzy logic problem. This handwritten character recognition belongs to your artificial neural network problem, and this money allocation problem belongs to your evolutionary computing problem. So out of this three belongs to your soft computing, and this B option, that is searching and sorting algorithm, this does not belongs to your soft computing. So this is your solution. So correct solution is B. So clear to everyone? Okay, Mini is saying yes. I hope this is clear. This is a simple question. I have started with a very simple question only, so that everyone can have a guess and can solve something. Okay, I think it is clear to everyone. Okay, nice. So we will move to the second question. Second question is, a set is defined as A equals a1 comma 0, a2 comma 0, a3 comma 1, a4 comma 0, a5 comma 1. It is a crisp set. Option A is it is a crisp set, option B is it is a fuzzy set, option C is both A and B, and option D is both A and B are not true. So can anyone wants to have a guess or wants to say the answer? Yeah, Divya is telling C, that is both A and B. Anyone else? Okay, no response. So Divya Jiju, can you unmute yourself? Mini is telling C. Can you unmute yourself and say why it is not B? Divya Jiju, are you there?
Yes, sir.
Okay, so why do you think it is not a fuzzy set?
It is both a fuzzy set and a crisp set.
Yeah, why it is not a fuzzy set? Because in crisp set, the difference we know about crisp set and fuzzy set is crisp set only had elements, whereas fuzzy sets had both elements as well as membership function. So this 0 1 can be membership function, right?
Yes.
Yeah. So why it is not a fuzzy set?
It is a fuzzy set.
Okay, it is a fuzzy set as well as it is a crisp set.
Crisp set, yes.
Okay, okay. So why it is a crisp set? Because it has membership function.
It has membership function 1 and 0. So
Okay.
if 1 means it is belongs to a set, and if 0 means it does not belong to a set.
Yeah, very good, very good. So Divya is very right. Let me explain you all. Yeah. So thing is that when we write any crisp set, we write only elements like A1, A2, A3, A4 and A5. But when we write a fuzzy set, we write elements as well as its membership function. Like yeah, membership function is a similarity of elements occurring to a class. Like we have a set called set having the hotness of a beverage. Like I term tea as 0.9, coffee as 0.8, something like cold drinks as cold drinks as 0, or something like that. So this is your fuzzy set. Means the membership function means how similar the elements belong to the class, how similar the beverage belongs to that class of hotness. That is the example. Now here you can argue that 0 is means membership function is there for every element, so it is a fuzzy set. But the answer will not be correct. The answer will be C, because 0 and 1. 0 means the elements belong to this class. Means if I tell give you a crisp set of hot things, so give a crisp set of cold drinks, so you can write one element cold drinks, right? But excuse me, someone joined. Okay. Yeah. So what I am telling is the beverage cold drink. If I want only cold items, then I can write only the element beverage called cold drink, like right, and not coffee or tea. So that belongs to a crisp set. So here also similar thing you can do, that where there is 0, you can you can like A1, A2 and A4. There you can omit these elements. So show you the solution. Yes, you can omit these elements A1, A2 and A4. So, and you can write this as a crisp set A3 and A5. So this set is both your crisp set as well as it is a fuzzy set. So answer is both A and B. So this is your answer. And more about difference of crisp set and fuzzy set. Yes, see, crisp set only one elements. Only we are writing the elements, like S belongs to this set. S belongs to this universal set X. So we are only writing elements and not membership function. Whereas in fuzzy set, what we are writing, element as well as this membership function. Mus is the membership function of this element S. So this is the main difference between your crisp set and fuzzy sets. So here it is a collection of elements, whereas here it is collection of ordered pairs, that is set as well as its membership function. And third thing is third thing about crisp set is it has a definite boundary, whereas fuzzy set it does not have a definite boundary. Means like three elements I have given. One is that cold drinks, coffee and tea. This thing about tea and coffee, if we are only interested in hot beverage, so we can't say it totally hot because it has some membership function 0.7, 0.8. So we can't completely put in this in the crisp set. So this is fuzzy in nature, means it is uncertain, it does not have any fixed boundary. So that is why it is known as fuzzy set. Another question I want to ask you guys is this membership function and probability the same thing or different thing? Anyone wants to answer? I am again repeating the question, is this membership function and probability same thing or different thing? Anyone wants to have a try? Mini, you want to try? Am I audible? Hello?
Yes, sir.
Yes, am I audible? Hello? Yeah, I am audible. So Mini, can you tell the difference between probability and membership function? Is it same or is it different?
Sir, it have a difference. In fuzzy set, we talk about uncertainty, and in probability, it is occurrence of chance.
Yes, yes, very good, very good. So what Mini has told is absolutely right. In membership function is similarity of element belonging to the same class. Like hotness, we are talking about hotness. So how hot it is, this is your membership function. Whereas probability is occurrence of element belonging to the set. Like occurrence of A3 will be half, as well as occurrence of A5 will be half. That means probability of element A3 is also 0.5, whereas probability of element A5 is also 0.5. But it could have a different membership function. Like if A3 is coffee, then it can have hotness of membership function 0.7. And A5 is your coffee, A5 is your tea, then it can have hotness membership function 0.8. So this is the difference between probability and this membership function. But both this probability and membership function will vary from 0 to 1. And difference I have already explained. So let's move to the next question. The set of points x in a fuzzy set A is defined as a core if membership function of element x equals to 0. Membership function of acha, a is the set. Membership function of all elements of a is greater than 1. Membership function of all elements of a equals to 1, or membership function of all elements of a less than 1. So anyone wants to have a guess? Anyone wants to guess this question? Or if you are sure, you can. Yeah, Divya is telling C. Okay. Anyone else?
Yes, sir. Yes, sir. C.
Okay, C. Okay. So let's see the answer. Let me explain you this answer. So core, yeah, absolutely correct. Core of a fuzzy set is defined as the elements whose membership function is equal to 1. Like in this diagram, the portion with this red line is the core of your set, because the membership function of this is 1. So this portion denoted by your red line is the core of your fuzzy set. Whereas there is another thing called support of fuzzy set. Support of fuzzy set is all the elements with membership function greater than 0. So in this, if this is your x1 and this is your x2, so apart from this x1 and x2, because the membership function of x1 and x2 is 0, right? This is the membership function, and x1 and x2 it is 0. So apart from this x1 and x2 element, all the elements in between x1 and x2, all the elements are known as support of the fuzzy set. So I hope answer is clear to you all. So answer is C. So this is a straightforward question. Another thing, how to read this graph. See, in any fuzzy logic graph, you have two axes. One is your x-axis and is your y-axis. In x-axis, you will have the elements, like x means all the elements x1, x2, x3, x4, x5. This will belongs to this x-axis. Whereas in y-axis, you will have the membership function, like mu1, mu2, mu3, and so on. So like if I have element x4 here, so the membership function of x4 will be 1. So solution is already clear, I hope. So nothing to explain more about this. I hope it is clear. So we will move on to the next question. If a problem cannot be solved using soft computing and hard computing, then which method you need to apply? Option A is your cloud computing, option B hybrid computing, option C is green computing, option D is grid computing. So anyone, I want everyone to answer this because I have already explained this. Am I audible? Hello guys, am I audible? Yeah, Min is telling B. Anyone else? Divya is telling yes. Yes, I am audible. Okay. So, what is the answer of this question, Divya? Okay, B. Very nice. Yeah, Divya Gupta is also telling B. Very nice. So yeah, so this is self-explanatory. I have already explained you this topic as a whole. So the option is B, hybrid computing, and nothing to explain you more. This also I have explained you. So hybrid computing, combination of conventional hard computing and emerging soft computing. So correct answer will be your B. So this question 5, given two sets A equals to 1, 2, 3, 4 and B B equals to 3, 5, 7. Relation R is defined. R consists of elements A, B, in which B equals A plus 2 and A, B belongs to A cross B. So these are the 4 option given. So yeah, so this anyone wants to guess, or anyone had solved it, or anyone had studied about it? Relation, fuzzy relations. Okay, so let me solve it. Will not ask about it because this I will solve it. So see, the elements of A we can write as one as A1, one as A1, 2 as A2, and so on, like 3. And 3 and 4 as A3 and A4. And sorry, there is some technical problem. Yeah, and set B we can write, we can assume these elements as B1, B2 and B3. So so this A cross B, how we calculate? We take element of A and we relate it with elements of all the elements of B, like A will be related, 1 will be related to 3, 1. Yeah, so 1 will be related to 3, one will be related to 5 and 1 will be related to 7. Similarly, 2 will be related to 5, 2 will be related to 3 and 2 will be related to 7. And similarly for 3 and 4. So A cross B you can calculate. A cross B will be 1 3, 1 5, 1 7, 2 3, 2 5, 2 7. Similarly 3 3, 3 5 and 3 7. Then 4 3, 4 5 and 4 7. That will be your A cross B. But let me erase it, otherwise it is not, you can't see everything. But in this question what has been asked is B should be A plus 2. So the element B should be A cross A plus 2. So in this you see this 3 is 1 plus 2. So this will be we will keep in our relation. Here this B is A plus 4, but we want A plus 2, so this we can't keep in our relation. Similarly this B is A plus 6, again we can't keep in relation. This is B is A plus 1, so again we can't keep in relation. This B is A plus 3, so again we can't keep this in relation. This B is A plus 5, so again we can't keep in relation. This is 3 means B is A, so again we can't keep this also in relation. This B is A plus 2, this we can keep in relation. This again we can't keep in relation. This is B is A minus 1, so again this also we can't keep in relation. And this B is A plus 1, so again this also we can't keep in relation. And this B is A plus 3, so this also we cannot keep in our relation, because our relation is B equals A plus 2. So the elements that remains in our relation is 1 3 and 3 5. So here to explain you this, the elements of in A is written in rows, whereas elements of B is written in columns. And we only got these two elements 1 3 and 3 5 in our relation. So A1 is 1 and B1 is 1, so B1 is 3, so this stays, so 1 3 stays, so here we have written 1, other all does not stay, so where it has not stayed we have written 0. Similarly 3 5 stayed, so we have written 1 in A3 B2. A3 is your 3 and B2 is your 5, so this stayed, so we have written 1, and other we have written 0. So your answer is A. See, 1 3 stayed and here 3 5 stayed, so this is your answer. So is this clear to everyone? Hello, am I audible?
Yes, sir.
So is this clear to everyone?
Yeah.
Yeah? Is this clear to everyone? Hello? Okay, Divya is telling yes. Okay. I think this is clear to everyone. Yeah, last step repeated. Okay. So last step, yeah, so up to this is clear, right? R will be 1 3 and 3 5. This is clear, right, Mini? Because B is A plus 2. Yeah, this is clear. So in last step what they have given is a matrix. And how they have given a matrix? They have given a matrix as the first element will be in row form, and the first set will be in row form, and the second set will be in column form. So what they have done is where the elements are present, like it is present A1 B1. A1 B1 is what? 1 comma 3. A1 is 1 and B1 is 3. So A1 B1 is 1 comma 3. So A1 B1 stays, right? 1 comma 3 is in your R. So you have written 1. But about other elements like A1 B2. A1 B2 is what? 1 comma 5. 1 comma 5 is not in your R, not in your relation, right? 1 comma 5 is not in your relation, so you put 0. Similarly, check a1 b3. A1 b3 is 1 comma 7. 1 comma 7, again it is not in your relation, so you again put 0. So you put 0 because 2 3 is also not in your relation, 2 5 2 7 3 3 is not in your relation, but 3 5 is in your relation. 3 5 is a3 and b2. So where you search a3 and b2, and as a3 and b2 is in your relation, you mark it 1, and other where it is in your relation, you mark it 1, other you mark all 0. Okay, so many got it. So anyone else has some doubt about it? Okay, so let's move to the next problem. So next problem is R is given a set and S is given a set, and we have to find T, which is max min operation of R and S. So again it is a tricky question. So what you have to do is you have to do the max min operation. Now there is a formula for max min operation that I have written. Formula is x1 z1 equals to maximum of minimum x1 y1 and y1 z1 and minimum x1 y2 and y2 z1. So this is confusing. I know this is confusing. So what I will do is I will tell you in simpler terms. So everyone has done matrix multiplication, right? Everyone has done matrix multiplication, right? Can you all respond? Yeah, matrix multiplication everyone has done. So we will be treating this question similar to this matrix multiplication. So what we will do is matrix multiplication, what we do is we multiply row of the first matrix with column of the next matrix, right? In something like this, we do this and we do this. So what we do is we multiply 0.3 with 0.9 and then 0.5 with 0.3, right? So similarly, similar thing we will do in this case also. What we will do is we will take this and we will take this row and we will take this column. So in this row we will match this element with this element and do and make the minimum of it. So what is minimum of 0.3 and 0.9? It is 0.3, right? And next thing we will match this element with this element. So what is the minimum of 0.3 and 0.5? Minimum of 0.3 and 0.5, again 0.3. So what is the maximum of 0.3 and 0.3? Maximum of 0.3 and 0.3 is 0.3. So our first element will be 0.3. So I am again repeating it. What you will do is, like matrix multiplication, you relate you do the operation on first column of your one set and first row of your one set and next and the first column of your next set. So and relate the elements. You relate first element of first row with first element of first column. So when you are relating 0.3 with 0.9, what you do is you do the minimum operator, right? So here first element is written as x1 y1. So x1 y1 is 0.3, right? And second what you do is second y1 z1. Y1 z1 is this one, this 0.9. So you do the minimum operation of this thing first. So what is minimum of 0.3 and 0.9? Minimum of 0.3, 0.9 is 0.3. Now this part is over. We are done with the first part. Now we will do the second part. Second part, what we will do? We will deal with second element of the first row and second element of the first column of second set. So now we will do 0.5 and 0.3. I am making two circles over it to make you understand. 0.5 and 0.3. So what is the minimum of 0.5 and 0.3? The minimum of 0.5 and 0.3 is again 0.3. So we are done with the second part. Now we have 0.3 over the first part and 0.3 over the second part. Now we will do the third part. Third part is maximum of this two. That is maximum of point. Here we got point. Sorry. Yeah, here we got 0.3. Here also we got 0.3. So now we have to do the third part. Third part is we have to do maximum of 0.3 and 0.3. So maximum of 0.3 and 0.3 is what? It is all 0.3 only. So we are done with this first element, and first element is 0.3, and we have to repeat the process for the remaining element. So next what we have to do, like next we have to go to the first row and second column. Like you have to do the minimum of 0.3 and 0.5. 0.3 and 0.5 is what? 0.3 minimum. And then 0.5 and 0.2. 0.5 and 0.2 minimum is 0.2. So in first part we are getting 0.3, and the second part we are getting here is 0.2. So what is the maximum of 0.2 and 0.3? It is 0.3. So next element will also be your 0.3. So you will do the similar thing, and your correct answer will be A. So this is your correct answer. So you can verify it. You can do this after class also. So I hope this is clear. Anyone wants to ask anything about it? Am I audible? Hello? So many, yes sir. So no doubt about it, right? If you want to ask some doubt, you can ask. So is it clear to everyone? Yeah, I am audible. So is it clear? Is question number 6 clear?
Yes, sir.
Okay, nice. So let's move to the next question. So next question is relation is given, and what you have to do is you have to actually the question is incomplete. What you have to find is you have to find R dash, that is the complement of this matrix. So how to find the complement of this matrix? You have to just just apply this formula. The complement is right r bar x comma y, and it is 1 minus r x x comma y. So what you have to do is 1 minus the element, you have to do this. So 1 minus 0 is 1, 1 minus 1 is 0. So let's see, first element is 1, second element is 0, third element 1 minus 0 is 1. So third element is 1, fourth element 1 minus 0 is 1. So we are 1 0 1 1 1 0 1 1, which option? 1 0 1 1 1 0 1 1, B, C and D. So A, I am cutting this. Let's see the remaining. 1 minus 0 is 1, 1 minus 0 is 1, 1 minus 1 is 0, and 1 minus 0 is 1. So it could be B, C, D, anything. Third is 1 minus 0 is 1, 1 minus 0 is 1, 1 minus 0 is 1 minus 0 is 1, and 1 minus 1 is 0. So it could be B also cut, because 1 1 0 is not there in B. So it would be out of C and D. So 1 minus 0 in all the 4 elements, 1 minus 0 is 1. So your correct answer will be D. So this is the correct answer. Correct answer is D. So nothing you have to do. Complement, you have to just do the 1 minus the element. So 1 minus, you will do all the element, and you will reach with this is also wrong. You will reach with option D. So this is very straightforward. I hope this is clear to all. So this is clear, right? Very straightforward question. You just have to do 1 minus the element. Okay, nice. Min is telling yes. So let's move to the next question. A membership function is defined as, you can read the membership function. So it is a triangular membership function, trapezoidal membership function, sigmoidal membership function, or Gaussian membership function. So anyone wants to have a guess on this? Anyone wants to have a guess? Or who know the answer? Question number 8. Yeah, Min is telling C. Anyone else? Okay, so this is also a straightforward question. If you had gone through the lecture notes, you would clearly able to answer this question. So the answer is C, sigmoidal function. So you can see the graph of the sigmoidal question. This is a snap taken from that lecture notes only. And sigmoidal, if it is your fx, then it the equation of this is 1 by 1 plus e to the power minus x minus c by a. This is your membership function equation. So nothing more to explain here. So your answer is C. So we are now to question number 9. Which membership function is known as Cauchy membership function? So anyone wants to have a guess of this? Is it sigmoidal? Is it generalized Bell? Is it Gaussian or is it triangular? Yeah, Min is telling C. Anyone else? Yeah, Divya is also telling C. Okay, so this is also a straightforward question. This is also a simple question. So again, if you had gone through lecture note, it is clear. So this is your Cauchy membership function or generalized Bell membership function. How its name came? Its name came from shape, right? This shape is totally looking like a bell, so that is why it is a generalized Bell membership function, or it is also known by this term Cauchy membership function. You can see this equation 1 by 1 plus x minus c by a mod to raised to the power 2b. So nothing to explain more of this. So answer is your C. Now what is the form of fuzzy logic? It is a two valued logic, crisp set logic, many valued logic, or binary set logic. Anyone wants to have a guess? Yeah, C. Harshita is telling C. Very nice. Okay, so again it is a simple question. Membership function, I have already told it can have any value between 0 and 1. So your two valid logic is your crisp logic. These two are very same. And your yes, it is also known as binary set logic. So A, B and D are same, but this fuzzy logic is a many valued logic. So this is your answer. So like the previous example only I have no, this is a new example. So like fuzzy set as like many valued logic, so it can have membership function between 0 to 1. So A1 has membership 0.3, A2 has the 0.4, A3 0.7, A5 0.5 and A4 1. So this is a many valued logic set or the fuzzy set. So your correct answer is C. Now this is your question number 11. The room temperature is hot. Here the hot used for linguistic. Here the hot use of linguistic variable is used can be represented by A is your fuzzy set, B crisp set, C fuzzy set and crisp set, and D none of the mentioned. So anyone wants to have a guess about this question? Yeah, Mini is telling C, sorry D. Anyone else? Yeah, Divya is also telling D. So let's have the answer. The answer is C. Fuzzy logic deals with your linguistic variables. Like all the linguistic variables like hot, good, or any parameter like the apple is red means how much red. It can have a membership function 0.8, 0.7, 0.5 like this. So this linguistic variable like the student is good, but this good is not a crisp, like good to me, good may not be to you. So this is an uncertain thing. Linguistic variable is always an uncertain thing, right? So as I have already told you that when the things are uncertain, that means we use this term fuzzy logic. So fuzzy logic or fuzzy set. So uncertain means we will go with fuzzy set. So here the answer will be your A. So question number 12, in the membership function graph x-axis represents. Yeah, Harshita is telling A. Anyone else? Okay, so let me show you the answer. So membership function x-axis I have already told. X-axis consists of all the elements of the set, or an element consisting a set consisting of all the element is known as universe of discourse, or the universal set. Universal set you must have heard in Chris set. Here what we call is universe of discourse. So this x-axis contain the whole universe of discourse, whereas the membership of this elements is represented in y-axis. So your answer will be A. So this is the 13th question. Which of the following equation is the equation for disjunctive sum? Disjunctive sum. So this you might have studied. Yeah, Divya is telling C. Anyone else? Okay, Mini is also telling C. So let me show you the answer. So disjunctive sum, yes, disjunctive sum is A complement intersection B complement union A complement intersection B complement. That means if I take two set like this and like this, like this, if this is your A and this is your B, then according to disjunctive sum the element will not belong to A, if complement is written, that means the element does not belong to this set. So A complement means the element will not belongs to A. Intersection means and the element will belongs to B. So that means the element belongs to A and element will not belongs to A. So let me highlight it. It will be more clear. So this portion, right? Half is this portion, and in our second part it is union. Union means or this element belongs to A and this element does not belongs to B. That means this part. So apart from this remaining part, that is A intersection B, this disjunctive sum means element belongs to A, element does not belongs to A, and element belongs to B. That means this part. And second part is element belongs to A and element does not belongs to B. That means this part. So apart from this A intersection B, all the shaded portion is your disjunctive sum. So I hope this is clear. And there are other terms also. Let me erase it. Yeah, there are other terms also, like sum you can calculate by this formula. Difference you can calculate by this formula. Disjunctive sum I have already discussed. And there are other two things also. One is bounded sum and another is bounded difference. Bounded sum is a minimum of 1 and this addition of the membership function. If there are only two elements in a set, x1 0.4 in A set x1.4 and in B set x2 0.3. So it will be minimum of 1 and 0.3 plus 0.4, that is minimum of 1 and 0.7, that is 0.7. So this is your bounded sum. And the thing is bounded difference. Bounded difference is maximum of 0 comma mu a, that is membership function of a plus membership function of b minus 1. So mu a value is 0.3 and mu b value is 0.4, right? So 0.3 plus 0.4, that is 0.7, minus 1 is minus 0.3. So maximum of 0 and minus 0.3 is 0. So this will be your bounded difference. So I hope you all understood this concepts. Can I get a response? Okay, Harshita is telling yes. Okay, nice. So we are left with another two sums. So which of the following is not a type of membership function? S-shape, bell-shape, truncated Gaussian, and D is none of the mentioned. So can anyone guess this? Can anyone guess the answer? Am I audible? Can anyone guess the answer? Okay, Minnie is telling D maybe. Okay, nice. So there is some confusion regarding this question. So yeah, Minnie, you are right. It is D. So all this are type of some membership function like S-shape, bell-shape, and truncated Gaussian. Here you can also see the graph of this. This is sigmoid or S-shape. This is known as S-shape membership function. This is the bell shape already discussed, and truncated Gaussian. Gaussian, you can say this, and if we cut this curve, like if we cut this like this, so we are actually truncating it. So this is also a type of membership function. So your answer is D, that is none of the mention. All are some type of membership function. So D is the answer. It is clear, right? Hello? Hello? Okay, nice. Harshita is telling yes. Many is also telling yes. So yes. I hope you are clear with truncated Gaussian also. This Gaussian, if we truncate or we cut the curve, then this Gaussian function is known as truncated Gaussian function. So now question number 15. A fuzzy set A is closed if these are the four options given. So anyone wants to have a guess? Hello? Anyone wants to guess? Yeah, Divya Jiju is telling B. Anyone else? Okay, so let me tell you the solution. So yes, Divya is absolutely right. Answer is B. a fuzzy set is closed if its end element is 0. Like if this is x1 and this is x2. So if these two are 0, then we can tell this fuzzy set is closed. That means if it is not closed, then it would have looked something like this. See, this is also not 0, this end element is also not 0. So if the end element is 0, then we can say this fuzzy set is closed. And out of this option, we can see in B only this end elements are closed or 0. Other in A we can see the first element is not closed. So this will not be your answer. In C also we can see that the end element is not closed, it is 1. So again this is not the answer. And in option D you can see both these elements are 1 1. So again this is not 0, so this is also not your option. So your option will be B. So this is what it is written, and your correct option is B. So I hope it is clear, right? What is a closed fuzzy set? If your first element and last element is 0, then this type of fuzzy set is known as closed fuzzy set. It is clear, right? Okay, very nice. It is a simple concept. If your first element and last element is 0, it is known as closed fuzzy set. So this is a simple concept. So with this, we are ending the presentation of today, or week 1 discussion. So if anyone has any doubt, we can clear it. We have 10 more minutes. So if anyone has any doubt, you can clear it from me. Otherwise we will end the session of today. Any more doubt? Any portion you found it difficult, or you want me to again have a look on that or discuss it? Okay, Divya is telling my all clear. Okay, I think everything is clear to all of you. So let me close this session today, and we will meet on next Tuesday 6 to 8 p.m. Okay, thank you all of you for your patience. Okay, very nice. Thank you. Okay, thank you. Okay, bye guys. Hello Rohit. Hello. Rohit, are you here? So Rohit, the class is from 6 to 8 p.m. I have just terminated the class. I think you are a bit late today. Okay, no problem. All this this will be video will be uploaded on a YouTube channel, as well as this this presentation will also be shared with you. So not so there is not any issue. Okay, Rohit. Okay. So bye. Thank you, all of you.